All right, so now we're in chapter 10 on this is 10.1 on the constant E and continuous compound interest. So we're going to talk about the constant E and also continuous compound interest. So for a definition, we have the number E. So E can either be listed as the limit as n approaches infinity of 1 plus 1 over n to the power n, or E is equal to the limit of 1 plus s to the 1 over s as s goes to 0. Both of these will give you a value of 2.718281, and so on. I'll leave the more formal definition and proof to you to read in the book, but that's what we really need. That's the key number we need, and we need to know that E is the number that we can actually use. All right. So with continuous compound interest, on one hand, if a principal, which we usually label as P, is borrowed at an annual rate R, then after T years at simple interest, the borrower still will owe the lender amount A given by the formula A equals P plus P times R times T. And remember, that's just interest. And so this is really equal to P times 1 plus R T. And this is kind of our simple interest formula. On the other hand, though, if interest is compounded m times a year, then the borrower will owe the lender amount A given by A equals P times 1 plus R over M, all to the power MT. Now, this is compound interest, and we're going to label this as Formula 2 because sometimes we refer back to it. Now, here R over M is the interest rate per compounding period, and MT is the number of compounding periods. So rate, maybe you have 0.06. We're doing it monthly, so M is 12. So we put 12 here, and we're doing it for 20 years. So we take 12 times 20, and we'd get our number of compounding periods. And so that's how that's going to work. Now, if we keep the P, R, and T fixed in equation 2, again, this equation here, and we pull P outside the limit using properties of limits, then what we can do is we get the following. So we're going to get the limit as m approaches infinity of P times 1 plus R over M to the MT. And then we can just work our way down. And guess what? This ends up being, we saw that before, that was the E. And so then we have P, E, to the RT. And so we're just kind of replacing all this stuff with the E function or the number. And so now we have the continuous compounding interest formula. And so usually that's going to be A equals PE to the RT. And way to remember it is PERT, PERT. Okay, so that's a formula that's widely used not only in business and economics, but in a lot of math classes. So we show you how to make and get compounding interest. So again, like I said, A is usually how we list the future value here. And so the continuous compound interest formula, if a principal P is invested at annual rate R expressed as a decimal, compounded continuously, then the amount A in the account at the end of T years is given by that formula. So let's look at an example here. It says, what amount to the nearest penny will be in an account after 5 years if $100 is invested at an annual nominal rate of 8% compounded annually, semi-annually, and continuously? All right, so we're going to have three equations basically. And so the first one we're going to do is we're going to do the annually. And what does that mean? Oh, that means n is equal to 1. Okay, so our equation there is just using compound interest. So we're putting a principal of $100 times 1 plus, our rate is 0.08 divided by 1, and that's to the m times 5 years, so 5. And we can plug that in our calculator and we'll get a value. And so what we'll do is we'll get all these and then we'll go and get them in our calculator. Semi-annually. So that one is n is equal to 2. So same thing, A equals 100, 1 plus 0.08 over 2, 2 times 5. And then continuously. And so this is when we use PERT. And so here A is equal to 100, and that's P E to the R times T. And we'll get a value. All right, so let's go get those calculations. And so our first one was we had 100 times 1 plus 0.08 divided by 1 raised to the power, that was 1 times 5. So we get 146.93. And it said to the nearest penny, so we'd round that one, just leave it as it is. Now we're also going to do this semi-annually. And so this will now be a 2 and This will be a 2. And so now we get 148.02. And our last one was with continuously compounding. So P E to the R T, and we get 149.18. So now we can go write those all down. So we ended up with this one. We said it was 146.93. This one we said is 148.02. And this one we said it was 149.18. So that's how we use compound interest, different compounding periods, and the continuously compounding interest formulas to find out the future values. All right, so let's stop there and we'll come back for more.